Hello guys, good day. Welcome back to our lesson. So in this video, we are handling our third quarter examination for robotics. First of all, I want to say sorry because we're having some rain outside. So now let's start. So for the third quarter examination for robotics, we should have done individually, build and design an Arduino project using your Arduino kit or the Tinkercad.com. The project must use at least three components that were introduced in modules 1 and 2. The project must be unique, meaning it must be different from the given assessments in module 1 to 2. Be specific about the functionality of your project. For example, using a potentiometer, control the resistance of an LED. Turning the knob will increase and decrease the frequency of the LED blinks. So now let's start. So first, I will inform you that this is my output for the third grading exam. Okay, let us just. So I will not manually start from the bottom because I've spent, I guess, 1 hour for this. So let me just sum up the step-by-step procedure that I've made. Okay, so here we are. The main tools that we need are the Arduino Uno, the LCD 16 by 2, and the breadboard. Next is the potentiometer, which has 250 kilo ohms, and resistors, which has 220 ohms, and LED. And also don't forget the jumper wires. So in this project, I've had a lot of jumper wires to be used. So this is my overall project. So let us see from the top. Okay, that's good. So up to the bottom. Okay. So let us first observe how did I went with the simulation. Like, what is the result of my simulation? Okay. So let's start, I guess. So observe first the okay, let me explain first. So from the assessment, it should have at least three components. So the first component that I've used is from the module 1 assessment 2 by using the LED and the resistor to the Arduino Uno. Okay. So each of these has wires. What you call this? Okay, I will explain later. After that, the next component is the module 2 assessment 2, or what you call the shadow night shadow scrolling circuit, scrolling LED, which is like from here it will turn on, then turn on, turn on, turn on, turn on, turn on, turn off, turn on, turn off, and then back and forth. Okay, I guess you can understand what I'm trying to relay. Next is the last component, at least three. So I've only used three for the foundation. But I guess all in all, it starts with the first foundation, which is the use of the LED and the Arduino. Okay, with the jumper wires. So the last component that I've used is the module 2 assessment 4, or the use of LCD component with potentiometer. Okay, so let's start the simulation. Observe, guys. Wait, let me just change myself up here so you can observe further. I guess I should put that here. Let's go start. Okay, so you observe the lights here, and then there we go. Um, for the wordings, guys, that's my personal wording. So, hello, I'm Brent. I'm 18 years old. I'm at MMCM. I live at Davao. My love name is name like that. Okay. To be honest, I actually had fun making this because I really want to create something that like for my trip or something like that I want to do, and I want to showcase my love for her. So I did just like that. So let's start explaining. Okay, so first of all, I've all connected the wires needed by the LCD. So wait, okay, let's start here. We need some power for the breadboard. So the negative for the ground, we shall connect that to the Arduino Uno. Right here. Here, the black one. Like that. Okay. Okay, that's like that. Next is for the power for the Arduino, we have the red wire connected to the 5 volts here. Like that. Okay. After that, so now our breadboard is usable. So now let's connect. So starting from the ground in the LCD, I've used this one, the black one, connected to the negative port of the breadboard. Next is the power connected to the positive port of the breadboard. After that, the contrast, we connect this one, this yellow mark connected to the potentiometer. Okay, this one. After that, the register select, we connected that to the number 13 for the D. And then for the read and write, I guess you can see that I've connected it to the positive, negative port for of the breadboard. After that, the enable connected to the number 12 block here. Afterwards, skip this, skip. Next is DB4 connected to the fourth, connected here. Let me bring it up. Okay, so this is how it looks like if I stretch out the LCD. So the DB4, this one, is connected to the number 4, which is the highlighted part. Okay, you can see that. Next is DB5 connected to the 3, DB6 connected to the 2, and DB7 connected to the 1. Next, after that is the LED connected to here. We connect that with a resistor in order not to have too much volt for it to crash the LCD. Okay, because resistors can minimize that one. Connect it to the power to the positive port. And after that, the LED cathode, we connect that to the negative. So let's return now the LCD. Next is the potentiometer. I guess you can understand here since the terminal 1 is connected always to the negative side and the terminal 2 is always connected to the positive. Same here goes with the resistors. Terminal 1 connected to the uh, anode, terminal 1, and then terminal 2 connected to the cathode or negative, something like that. Okay. After that, we change the colors for the LEDs to our own perspective. And after the LCD, we connect. Okay, the wirings for the bulbs here are here in the following. This one, yellow, orange, red, white, red, orange, yellow. Okay, so this one, the wirings here is the yellow one. Let me pull again this in order for you to observe. I guess it will do here. That should do. This one, the yellow one, connected here. The orange connected here to the 10. The red one connected to the 9. And the white one connected to the 8. Then here, the red ones here and connected to the 7, 6, and 5. So I guess you could say that we've totally used all here except for the 0. Okay, so I guess that's for the wires. So for the coding, now let's hop onto the coding. So first of all, we started with the hashtag include liquidcrystal.h, which is what we've used in the previous video, in the previous assessment, the module 2 assessment 4, right? Now, the only different thing is we specified the constant integers here, in which we've used rs equals 13. Here we go, rs for the register select, en for the enable here, 12, and then D4, D5, D6, D7. So for the INT timer, this is for the scrolling LEDs. Okay. Now we proceed to the void setup. So for the void setup, we've only used for the scrolling LED. We don't set up the LCD message and stuff. So in the void loop, this is now the place where we set up all of the contents for the LCD. Okay, so we observe, as you can observe, we first started with the here. Okay, 4 in integer. This pin equals 5 here. If this pin is less than 12, so less than 12, so all of this from 5. So this pin is plus plus. Okay, as we've explained in module 2 assessment 2. So digital write, this pin is high, where the delay is the timer. Timer here is 100, okay? And then digital write, this pin low. Now for another 4 integer, this pin equals 11 here. And then this pin is greater than 5. So all of the values greater than 5, like here. So more like opposite for the earlier 4 statement. So after the opposite, we change the positive positive to negative negative. And same delay timer and digital write. Now we proceed to the LCD setup as LCD loop. So start with LCD begin because it has 16 by 2 dimension. We put here 16 and 2. After that, we set the cursor from the number of the box. So we set it 5 here. So 1, 2, 3, 4, 5. This is the box which the letter H starts. So H E L L O, then exclamation point. After that, we've put the delay for 1500. All delays are in what you call this milliseconds. So we've continued copy that, but further we've changed it to 1000. I guess it's too fast, right? So we can change that to 15. And here for that hello, we've put it at 1000. So we've also changed this one to 5, this one to 15, this one to 15, this one to 15, so on and so forth. After that, after all the functions, always remember to not to miss the semicolon after all functions. So Now, as you can see earlier at the words written there, I have hello. I'm Brent. I'm 18 years old. I'm at MMCM. I live at Davao. My love is named Ria Daniela. I love her and always will. Hashtag Brent X Danny. So after all of that, after the void loop, we should put the closing, what you call this, brace for the coding to be finished. So let me replay again what we're having with the delay change, I guess. The colors and hello, I'm Brent. I'm 18 years old. I'm at MMCM. I live at Davao. My love is named Ria Daniela. I love her, and I always will. Brand X Danny. Okay. So I guess that's all for my third grading exam. So this the function here. Okay. So I shall explain the function, which is why I've created this output. It's because we can, for starters, we we tend to miss some timings for reading messages. So if we miss the timings for reading messages, I guess it can be detrimental in some information gathering. So in order not to miss the messages in the LCD, we first have the warning, which is the scrolling LED. That should serve as the warning for the machine, like what we've created. So after the warning, there goes the message afterwards. So it should serve as like more like emergency or something in order for the users not to be neglected onto the message given by the LCD. Like we can input our messages abruptly at the LCD, but we sometimes tend to neglect the fact that we are sometimes lazy, so we cannot ensure about the timing. So that is the function that I've created using the scrolling LED and the LCD with the potentiometer, changing its uh, intensity. Okay, you can observe it. Mm. So I guess that's all for this video. So this is my third grading exam in robotics. And once again, my name is Brent Paul Macasilhig, and I'm happy to be with you guys. See you soon for more videos. Goodbye.